Good afternoon, friends. Welcome to the session on permutation and combination. So, I am C. Rashmi Lonikar and I will be taking you through the session on permutation. Okay. So, now coming to the marks of how much marks they will carry, the session will carry. It is 30 to 50% of your marks are for these 4 chapters, permutation and combination, sequence and series, sets, relations and functions, and basic application of differential and integral calculus. So all these 4 together will constitute 30 to 50%. So you will get at least 2 questions on these chapters. So you can look into this. Now let us understand what do you mean by permutation and combination. Okay, so let us understand this. Now what happens here is that if I have here if I have a box of goodies, okay, so this is a box with many things, okay, and I want to give this to 5 people. So 1, 2, 3, 4, 5. There are 5 children are there. There is a box in which lots of goodies are there, and I want to give them to these. So when I want to distribute n articles, so I say these are n articles between r number of people, n articles between r number of people, so that I distribute these n goods with to these children. This is called as combination. Okay. Now, suppose child number 1 has got 4 goodies. Okay, he got 4 goodies. If I want to arrange these goodies, in a particular manner, this is known as permutation. Okay. Now you will ask, what is the use of all this? Why do we need to study permutation and combination? Does it have any practical uses? Yes, of course it has. In biology, you can see that RNA sequences uses permutations. Then when you are selecting menus, you use combinations. Or computer science, in algorithms, in analyzing, we are using permutation and combination. So this is an important topic which has practical applicability also. Okay. Now let us go to the first important thing that is important when we are talking about permutation and combination is we must understand the concept of n factorial. Okay. So n factorial is 1 into 2 into 3 into 4. So I must keep multiplying till when? Till I reach n. Okay. This is one way of writing it, or you can go this way, that I will write it as n into n minus 1 into n minus 2 into n minus 3. Up to where will I go? I will go up to 1. Now let us take an example for you to understand this better. So suppose I have 5 factorial. Okay, suppose I have 5 factorial. So 5 factorial can be written as 1 into 2 into 3 into 4 into 5. So 1 into 2 is 2, 2 into 3 is 6, 6 into 4 is 24, 24 5s are, okay, 24 5s are 120, right? I can also write this as, this is the number 5, so I will start with 5 and going down one place at a time. So 5 into 4, 5 minus 1 is 4, 4 minus 1 is 3, 3 minus 1 is 2, and 2 minus 1 is 1. So I get this 5 into 4, 20, 20 into 3, 60, 60 into 2, 120. Okay. So I have the concept of factorial. Factorial is 1 into 2 into 3 up to n. So in this, we have tried to find out 5 factorial. So 5 factorial is 120. So I can write it as 1 into 2 into 3 into 4 into 5. Or I can write it as 5 into 4 into 3 into 2 into 1. Okay. So this is the basic concept of factorial. So let me check. Yes, good afternoon, Nitil, Gunjan, Ishan, Srinidhi, Zeba, Chaitanya, Harshita, Lakshita, Bihu, Diksha, Rafika, Sarveshwar. Yes. Okay. Yeah. Now, so these are the some of the factorials that we have already found out, and as far as possible, try to remember them so that when you are doing the calculation, it becomes easier. These many, if you remember, you don't need up to 9 and 10, but still, I have just written it. Sometimes they will ask you how much is 10 factorial. So if you already know, it becomes easier for you. So here, as you can see, that 3 factorial is 6, 4 factorial is 24, 5 factorial is 120, 6 factorial is 720, 7 factorial is 5040, 8 factorial is 40320, 9 factorial is 362880, and 10 factorial is 3628800. Let me show you some of them so for your understanding. So as you know that 3 factorial is nothing but 1 into 2 into 3. So 2 into 3 is 6. Okay. Let us consider this 7 factorial. So 7 factorial, what do I write? 1 into 2 into 3 into 4 into 5 into 6 into 7. Okay. So 2 into 3, I know is 6. 6 into 4, 24. 24 5s are 120. 120 into 6 is 720. 720 into 7 is 5040. Okay. This you can also write this as 6 factorial multiplied by 7. Okay. 7 factorial, I can also write it this way, and I can also write it as 6 factorial into 7, or you can also write this as 7 into 6 factorial. Okay. So I can do that also, right? So similarly, 8 factorial can be written as 8 into 7 factorial. So if you know, if you remember 5 factorial is 120, then bigger numbers also you can easily find the factorial. Okay. Have you understood the concept of factorial? Because that is very necessary for you to able to do sums on permutation and combination. So let us see whether you have understood or not by taking examples. Yes. Thank you, Nital Varun. Thank you. You understood? That's great. So now let us go to this. You are asked to find out what is the value of 9 factorial upon 6 factorial. Remember, in this case, I can either write down what is the value of 7 factorial, 9 factorial, and what is the value of 6 factorial. So let us go back. 9 factorial is 362880. Okay, just let me put it this way. 362,880 upon 7 factorial is 720. So let us see how much is this. Where is my calculator? Come on. Let us all find it out together. 362,880 divided by 720. So the answer is 504. Okay, let us use the other method also. Why? Because I may not remember how much is 9 factorial. Then what do I do? So in this case, what I will write is 9 factorial upon 6 factorial. I will write from the bigger number up to the smaller number. Okay, so I will write this as 9 into 8 into 7 into, see this is 6. So I will go up to there into 6 factorial. Okay, upon 6 factorial. Okay. So I went from the bigger number to the smaller number. 9 into 8 into 7 into 6. So 6 factorial gets cancelled. What do I have? What do I have? 9 into 8 into 7. Let's see. 9 into 8 is 72 into 7 is 504. Okay. So here also I got the answer as 504. So whichever method you are comfortable with, just use that method so that you will be able to get the answer. Okay. So if you've understood this, let us see whether or not you can do 10 factorial. This is, I think I forgot to write. 10 factorial upon 7 factorial. Okay. So let us see 10 factorial upon 7 factorial. Let us see. So tell me which method would you like you to use, first method or second method? So if I use the first method, 3, 6, 2, 8, 8, 00, that is 10 factorial upon 7 factorial is 5, 0, 4, 0. So what is the answer? 3, 6, 2, 8, 8, 00 divided by 5, 0, 4, 0. Answer is 720. Okay. Let us use the other method. 10 factorial upon 7 factorial, which is equal to now bigger number up to the smaller number. 10 into 9 into 8 into 7 factorial upon how much? 7 factorial. So this 7 factorial and 7 factorial will get cancelled. And what will I have left with? 10 9s are 19, 19 8s are 720. Okay. Just let me know in the chat box whether you have understood till here. Excellent, excellent. Ishan, Devesh, Manjunath. Priya, what is this answer? Khushdeep, you don't have to learn, you have to just remember how to calculate, you know. They will not give you 9 factorial is this much. They won't give you. You must know how to use it. Okay? And you don't have to learn it also by heart. You can even do this way. No? You can multiply on the calculator there itself also. Yes, Lakshita. Thank you. Yes, Mohammed. You've understood. Good. Yes, Durgesh. Second method is better from the exam point of view. And if you're comfortable with the first method, you can use it. Depending on how much big the number is, you can use any of these methods. Yes. Priya, we will just reduce the calculation so that you don't need many shortcuts for this. Okay. Because you are already like, see, this is a shortcut only when you are taking the number 9 up to 6. So you are eliminating 6 factorial. So you don't have to multiply those. Only have to multiply how much? 9 into 7 into 8. That bit is very easy, you know. We can easily do on the calculator. Or even you can do it orally also, you know. So now let us take another example. And all these examples are from the study module that I am taking up. Okay. Now find x if 1 upon 9 factorial. So I have this 1 upon 9 factorial plus 1 upon 10 factorial is equal to x upon 11 factorial. Okay. Now we have fractions over here. What is important in fractions is that your denominator, try to make the denominator same. When we are trying to make the denominator same in normal sums, what do we see? We see the factors. But here we are factorials, okay? Because this exclamation mark stands for factorial, okay? This exclamation mark means what? It means factorial. Okay? So when this is the case, which is the biggest number? 11. Which is the smallest number? 9. So I will write 11 factorial in terms of 9 factorial. I will write 11 factorial in terms of 9 factorial. Then next number is 10. 10 factorial. 10 factorial I will write in terms of 9 factorial. So let us do that. Okay. This is what? This is 1 upon 9 factorial as it is because that's the smallest factorial plus 1 upon 10 into 9 factorial is equal to x upon, now 11 factorial I have to take up to 9 factorial. So this will be written as 11 into 10 into 9 factorial. Okay. 11 factorial I have written in terms of 11 into 10 into 9 factorial. So what will I do? I will take out 9 factorial from the denominator. So 1 upon 9 factorial common. 1 upon 9 factorial, what will remain is 1 plus 1 upon 10. Because from here, what I have done, okay, I have taken out this 9 factorial. I have taken out this 9 factorial over here. So what will remain here? Remaining is 1 upon 9 factorial. Here what will remain is 1 upon 10 factorial. So 9 factorial I have taken it out. So what will remain here is 1. Okay. So this is what I will have. Okay. Just let me. I will. Okay, so I have this as 1 upon 9 factorial. Now I have taken that common out. So what will I have here? This 9 factorial. When I have taken out, what will remain here is only 1. 1 will remain here. So 1 upon 9 factorial, 1 plus 1 upon 10. Is equal to x upon 11 into 10. Okay. Because I have taken out the 9 factorial. What is left in the left hand side is 1 plus 1 upon 10. And here when I take that out, I will write this as 1 upon 9 factorial. Now you have 9 factorial on both the sides of the equal to sign. This will cancel. This will cancel with this 9 factorial. Okay, so what do I have? 1 plus 1 upon 10. 1 plus 1 upon 10 is nothing but 11 upon 10. And what will happen over here? I will have x upon 110. Okay, I will have x upon 110. So we have x upon 110 is equal to 11 upon 10. Cross multiplying, I will take the 110 to this side and I will get x is equal to 11 into 110 upon 10. Okay. So this 0 and this 0 will get cancelled. I will have x to be equal to 11 into 11 or I have x is equal to 121. Is that clear? These are good sums which can fetch you marks also, and these are you will be able to do on your own also. All you need to do, remember, is Here, the important step is taking 1 upon 9 factorial common out from the equation, and then we will be left with the simpler one. Okay, hope you've understood this. Yes, Varun, thank you. Nital. Yes, Ustad and Rahul. Gunchita, yeah, very good. Okay, now let us go to the next one. We will now take a step further and we will say find n if this is also a method of writing factorial. Okay, you can write factorial like this also, and you can write it like this also. Okay, this I have purposely taken this one because there is a different symbol here. It is the same thing, but we will keep it the simple. We will always use the factorial sign. Okay, the exclamation mark sign. So this is n plus 1 factorial is equal to 30 into n minus 1 factorial Okay. Let me just check this sum because it is saying x upon 11. Just give me x 1 second. I don't think, I think it's only is equal to that much. Yes. The sum is only n plus 1 factorial is equal to 30. Yes. So this is the sum. I think this is the sum is up till here. N plus 1 factorial is equal to 30 into n minus 1 factorial. So now you must see which is the bigger number and which is the smaller number. Now is n plus 1 big or n minus 1 big? Which is the bigger number? When I am confused, I don't know whether which is big or not. So I will let me put n is equal to 10 and see. Now what will happen over here if n is 10? So this will be 10 plus 1. This is 10 plus 1. So this is 11. What will happen over here? 10 minus 1, which is equal to 9. So that means n plus 1 is bigger than n minus 1. So I will write n plus 1 up to n minus 1. So bigger number up to smaller number. So what I do over here is n plus 1 factorial. I will write it as n plus 1. Then I will subtract 1. I will go down. So this is n plus 1 minus 1. Okay. Then what will happen? This is how much? N plus 1 minus 1. Plus 1 minus 1 will get cancelled. So you will have n. Okay. So I will directly write this as here. So I have n plus 1 into n minus 1. N plus 1, I have taken out 1 from it. I will get n. From n, I am taking out 1 more. I will get n plus 1 factorial. This is equal to 30 into n minus 1 factorial. Now what happens here is this n plus 1, n minus 1 and this n minus 1 factorial will get cancelled and I am left with, so what is there? N plus 1 into n is equal to 30. N plus 1 into n is equal to 30. Two ways in which you can solve it, or rather three methods. Shortcut method, one is the long cut method is that I solve this. I will multiply n into n plus 1. I will get a quadratic equation. I solve it. I will get the answer. Second is that I take the options. Second, the simplest and the trick is that whatever options are given, I will put the value of n over here. I will multiply and see, and I will get the answer. The third method is when I'm not sure of the options, then I will do this thing. See, what does this mean? 30. Can I find out the factors of 30? 30 can be written as what? 3 into 10, right? It can also be written as 6 into 5, right? Now, what does this mean, n plus 1 into n? It means that these are two consecutive numbers, okay? This means that multiplication of two consecutive numbers should be equal to 30. Okay. This n plus 1 into n is equal to 30 means that multiplication of two consecutive numbers should be equal to 30. Are 3 and 10 consecutive numbers? What are consecutive numbers? Numbers that are appearing one after the other in the number line. 1, 2, 3, 4, 5, 6. So number, if I talk of number 9, if I talk of number 9 and 8, are they consecutive? Yes, they are consecutive. But if I talk of 9 and 7, are they consecutive? No, because then there is a number 8 over here. Okay, so I will have 8 over here. So these are not consecutive numbers. These are consecutive numbers. So 3 into 10, is it consecutive? No. 6 into 5, are they consecutive? Yes. So what does this mean is that my n is equal to 5 and n plus 1 will be equal to 6. And so I get the answer, value of n is equal to 5. Understood? Let me explain again that n plus 1 factorial is equal to 30 into n minus 1 factorial. I have this question. I remember that in permutation, I will write the bigger number up to the smaller number. So once I'm doing that, what will I do? I will write them up to the smaller number. So I have n plus 1 into n minus 1 factorial is equal to 30 into n minus 1 factorial. So n minus 1 factorial will get cancelled away and I am left with n plus 1 into n is equal to 30. Now I try to find the factors of 30. So in factors of 30, I have 2, 3 into 10 or 6 into 5. Which of these should I use? I have to pay attention to the left hand side. It says that n plus 1 into n is 30, which implies that the multiplication of two consecutive numbers should give me 30. Which are the consecutive numbers? 6 and 5. Okay. Or second, the quicker method, the shortcut is that I check all the options that are given to me and I will try to put the values, whichever values satisfy, that will be the answer. Third method, if you are still in doubt, sometimes you know that none of these is the answer, then what do I do? Then in that case, just simplify, use this, expand this equation, prepare the quadratic equation and solve it, you will get the answer. Okay. Okay. No, at the end you will not put the factorial sign, Pushdeep, because that is value of n. It is not factorial. It is the value of the number, and n is what? A simple number. Okay. Yes, Ritika, it is. Yes, Mitra, right. There's some printing mistake from my side. I mean, when writing it down. Yes, Bhargavi, n plus 1 is the bigger. Himanshu, factorial will never be a negative number. Isha, you have got this. See, when I'm writing 9 factorial, what do I write? It is 9 into 8 into 7, right? So what is happening? The number is decreasing by how much? 1. So similarly, when I'm writing n plus 1 factorial, I will first write n plus 1. Then I want to decrease it by this 1. So n plus 1 minus 1, I will get n. From n, I want to again take out 1. Okay, I want to subtract 1 from n. So what will remain? N minus 1. Like we did over here. Okay, difference is 1. Here also difference is 1. Okay, Isha. Okay, Kirti, you can't get a minus sign. So you have n is 5. Because two numbers multiplication you are getting, the value as given is 30. That is plus 30, isn't it? It's not minus 30. Vagdevi, again the same thing. The answer is plus 5. Yes, Gunshita, I hope you have understood why we are writing n plus 1 into n minus 1. We are just decreasing it by 1. Okay. Yes, Harnoor. N plus 1 factorial is written as n plus 1 into n minus 1 factorial. See, Varun, why can't n be negative? N is the number of things. Okay, can you have negative number of things? If I am talking about a box of pencils, it can be a maximum what it can be 0. Okay, I have a box which contains no pencil, right? I can't have negative pencil, right? That is not possible. That is why we don't take n as negative. Yes, Murtaza. Okay. Yes, Keshav, it is an MCQ format. So this will help you. Okay, and in the paper Bhargavi, you will get the place around the questions. You can solve it over there. Simple calculators like this one is allowed. Okay, so this calculator is allowed where you don't have more functions. You know, simple square root and percentages are there. That type of calculators you are allowed. Okay. And please use the same calculator from now till the exam. Okay, don't change the model. Otherwise, you will have difficulty in understanding where the plus sign is, where the multiplication sign is. You know, every calculator has different format. Okay. I'll just explain this sum again. So this is n plus 1 factorial is equal to 30 into n minus 1 factorial. Now I want to write down n plus 1 up to n minus 1. Okay, the n plus 1 is the bigger number, n minus 1 is the smaller number. So I will write this as n plus 1 into n into n minus 1 is factorial is equal to 30 into n minus 1 factorial. This n minus 1 factorial gets cancelled and I have n plus 1 into n is equal to 30. So I get n 5, this is 6 into 5 is equal to 30. So n is equal to 5 because n into n plus 1. So smaller number into bigger number. Which of them is the smaller number? 5. So n is 5. This n plus 1 factorial is written as n plus 1, okay, into, for those of you still have confusion, I will write n plus 1 minus 1 into n plus 1 minus 2 into n plus 1 minus 3, like this. Huh? You can write this like, so this is what, this is n plus 1. Now plus 1 minus 1 will become 0. Okay, this is plus 1 and this is minus 1. They will cancel out. Here I will get n. What happens here? This is plus 1. This is plus 1 minus 2. Plus 1 into and add minus 2. Plus 1 minus 2 will give me minus 1. So this is n minus 1. If you want to take it further, okay, suppose I want it this way. So then this will be how much? Plus 1 minus 3. Plus 1 minus 3 will give me minus 2. So this will become n minus 2 factorial. Okay, so you can write this up to any number where you want to take your questions up to. Okay, hope you this is clear. You practice it more, you will understand it. The more we do sums on it, you will be able to understand it better. Okay. Now there are fundamental principles of counting. There are two fundamental principles. One is the multiplication rule and the second is the addition rule. Okay. Let us understand what the multiplication rule says. Multiplication rule says that the first things can be done in m different ways, and when that thing is done, the second one can be done in n different ways. Then the total number of ways in which both the things can be done simultaneously is m into n ways. Okay. First thing is done in m ways. Once that is completed, second thing is done in n ways. Then the total number of ways in which the both things can be done is m into n ways. This is called as the multiplication rule. Now let us see with an example. Now, suppose A is standing over here and his school is here. Okay. There is this one road. This another road. Another road. This one road. So this is road number 1. This is road number 2. This is road number 3, road number 4, and road number 5. Okay. So these are the roads in which he can go. Okay. So these are 5 roads. So, or you can say these are 5 buses he can take. While going from A to the from his house here, he can take any of these buses. Route number 1, R1 bus route, R2, R3, R4, and R5. Okay. But what happens is this road, this special road over here, this R3 bus goes on this road, and this bus, this is a one way. Okay, this road is one way. So what will happen? This R3 bus, it will not be able to complete a circular journey. So when A goes from home to school, he can use bus number R1, R2, R3, R4, R5. Okay, but while coming back, he can use this R1 bus. He can use this R2 bus. He can use this R4 bus, and then he can use this R5 bus. Okay. So there are different combinations. So what will happen? A can go either by R1 while going to school, While coming back, he comes back with his friend by the route R5, by the bus route R5. Or he may come back by R4, or he may come back by R2, or he may come back by R1. Okay. So he can do this. And while coming back, so this is when he goes. Similarly, there will be while going, he may use R2. Again, he can come back by these many routes. Okay. So what this implies is that there are 5 ways in which 5 bus routes he can take while going. While coming back, he can take only 4. But what is the total number of ways in which he can go to school and come back? Okay. Total number of ways in which he can go to school and come back is 5 into 4, which is equal to 20 ways. And you can even, plot it and see. So there are 20 ways in which he can go to the school and come back. Is it wonderful that this is how this is used, to find out what are the options that a person has. Okay, in analysis, this is very important because I must know what are the options that person in front of me has. So this is the multiplication rule. What does the multiplication rule says that if the first things can be done in m ways, so here m is how much? 5. Okay. And once that is done, so once he has reached school, he wants to come back. So once that is done, the second one can be done in n ways. So when he's coming back, how many routes can he use? Bus routes he can use is 4. So the total number of ways in which both the things can be done. Okay, both the things can be done. This is not sun, this is done. Is simultaneously is m into n. So these are 20 ways in which we can do that. Okay. Understood? Let me see. Okay, right? Now, so this is the sum we did. Now, addition rule. What does addition rule says? If one job can be done in m ways, if one job can be done in n ways, one job, and alternative job can be done in n ways, then either of the 2 jobs can be done in m plus n ways. Suppose in the earlier example, we are saying that he is going by bus and he can go by bus in R1, R2, R3, R4, R5 bus routes he can take. While coming back, he can take R1, R2, R4 and R5 because R3 bus route does not go there. So what happens is we found out that there are how many ways in which he can go to school and come back? 5 into 4, 20 ways. Now I also want to know, do I have to travel by bus or is there a rickshaw available? So here I can say that the important thing is for A to go from home to school. Okay. So now he has an option. What is the option? He can take a bus or a rickshaw. Okay. So you saw the word or is coming into place, coming into use. So bus or rickshaw. So when you are using the word or, it implies you have to use the addition rule. Okay. So addition rule, when the word or is used. Multiplication rule is when the word and is used. Okay. So this is, if one goes to school by bus where there are 5 buses or by auto. Okay. So or by auto when there are 4 autos, then the total of number of ways of going to school is 5 plus 4, which is 9 ways. Okay, so now we have understood the concept of permutation. We have understood the concept of factorial, and now we will move towards permutation. What is permutations is that a way of arranging or selecting smaller or equal number of objects from a group of objects with due regard being paid to the order of arrangement. Okay, so permutation, when you are talking, our important word is arrangement. Arrangement. Okay, these are called as permutation. Suppose we have 3 students. So this is rank number 1, this is rank number 2, and this is rank number 3. Now what can happen? For the first rank, all 3 students are considered. So A or B or C. Once one of them is selected, suppose I select A for the first rank. What will happen? For the second rank, we will have the option B or C. Okay. Once I have selected one person here, suppose I have selected B, what will happen to position C, position 3? Only C will be there. Okay. There are 3 students, 3 prizes or 3 ranks, 1, 2, 3, and students are A, B, C. So then what will happen is I can have here, I have the option 3. So I have 3. Here it is 2, B or C, and here it is 1. Okay. So what this means is that 3 ranks can be given to 3 students. Okay, 3 ranks can be given to 3 students. So now I have to use which rule? I have to use multiplication rule, because I want to give the ranks all ranks 1, 2, and 3. Okay, so it can be given to 3 students. In how many students are available for the first rank? 3. So 3. For the second rank, 2. And for the third rank, 1. So 3 into 2, 6. 6 into 1, 6. Okay. So there are 6 ways of giving 3 ranks to 3 students. There are 6 ways of giving 3 ranks to 3 students. And this is represented by by this symbol NPR, or this is a formula also. What does NPR say? NPR is n into n minus 1. Okay, we have done this in factorial. N into n minus 1 into n minus 2 into how much will I go to? This is into n minus r, n minus r plus 1. Okay, out of n objects, when I am rearranging them and I'm taking r objects, so this is the formula. This can also be written as n factorial upon n minus r factorial. So you can solve it using this formula or this formula. The choice is yours. Munshita, can you increase the volume of your laptop or mobile, right? Okay. So somebody was asking about 0 factorial. So 0 factorial is always taken as 1. Now NPR is n factorial upon n minus r factorial. Important thing to remember is that when this n minus r is in the bracket, so I must use the BODMAS rule first. So I must solve the bracket first and then find the factorial. 0 factorial is 1. NPN, okay, NPN is equal to n factorial. N minus 1 factorial minus n factorial is n star n minus n star n factorial. I will show this example here. So this is n plus 1 factorial minus n factorial. Now what I do is I will write bigger number up to smaller number. So this will be n plus 1 into n factorial minus n factorial. Okay. This n plus 1 factorial is written as n plus 1 into n factorial. I take out common n factorial into bracket n plus 1 and minus. If I take out n factorial, what will remain is minus 1. So this is n factorial plus 1 minus 1 will get cancelled. This plus 1, this minus 1 will get cancelled and this will be n factorial into n. So this is written as n into n factorial. Okay. So I have shown you. So remember NPR is n factorial upon n minus r factorial. NPR is equal to n factorial upon n minus r factorial. 0 factorial is 1. NPN is n factorial. N plus 1 factorial minus n factorial is n into n factorial. Okay. And or you can also write NPR as n into n minus 1 into n minus 2. Up to where will I go? This is up to where? This is n minus r plus 1. Okay. So let us now try to find out the values of all this. 5p3, can you calculate? P3. This is equal to 5 factorial upon 5 minus 3 factorial. So how much is this? 5 factorial. BODMAS rule says that I will have to solve the bracket first. So 5 minus 3 is 2. So I will have 2 factorial. How much is 5 factorial? 720. 120. Sorry. And how much is 2 factorial 2? The answer is 60. 5 factorial is 120 upon 2. I can also use the other formula. Okay, NPR is n into n minus 1 into n minus 2 up to n minus r plus 1. So let me first see how much is n minus r plus 1. How much is n? 5. How many r? 3 plus 1. 5 minus 3 is 2. 2 plus 1 is equal to 3. So what will I use here? So 5 into 4 into 3. Because I have to go up to 3. So 5 into 4 into 3, which is equal to 12 5 is a 60. 12 5 is a 60. Okay. So this is using NPR. Okay. For which formula have we used? First we have used NPR is equal to n factorial upon n minus r factorial. What is the formula we have used here? This is equal to n into n minus 1 into n minus 2 n minus r plus 1. Okay. This both the formula for permutations we have used. Now let us see 10p2. Five p3 I have written as 5 factorial upon 5 minus 3 factorial, which is equal to 5 factorial upon 2 factorial, which is equal to 120 upon 2, which is equal to 60. Second is 10p2. Now how much is 10p2? This is equal to 10 factorial upon 10 minus 2 factorial. 10 factorial upon 10 minus 2 factorial. So this is equal to 10 factorial upon 10 minus 2 is 8 factorial. So how much do I get? I will write the bigger number up to the smaller number. So this is written as 10 into 9 into 8 factorial upon 8 factorial. So this 8 factorial will cancel out. I am left with 90. I am left with 90. So 10p2 is equal to 90. Let us see the third one, 11p5. This is equal to 11 factorial upon 11 minus 5 factorial, which is equal to 11 factorial upon 6 factorial. So again, I will use this. Or I can do on the calculator also, that is also possible. But then in the exam time, you may face a difficulty going up to 11 factorial. So I will write this from 11 into 10 into 9 into 8 into 7 into 6 factorial upon 6 factorial. 6 factorial will cancel out and you are left with, this is 5, 5, 4, 4, 0. Okay, let us check. 8 9s are 72. 72 into 10 is 100. 720. 9 into 8 is 72. 72 into 10 is 720 into 11 is 7920. 11 into 10 into 9 into 8 into 7. So this is 55440. Okay. So you can do this method. Thank you, Murtaza, that you like my teaching. Good. Yes, Malay. Very good. Very good. Kirti. Yes, Diksha. No, Khushdeep, the answer is not in factorial. The answer is in pure number. 60 is the number. When I say 5p3, that means that I have 5 articles. From that 5 articles, I want to choose 3 articles. Okay. So 5 articles, in the 5 articles, I have taken 3 at a time and I am arranging them. So that can be done in 60 ways. Okay. We will be doing the word problems, then the concept will be more clear. Okay. Right now, remember that these answers are not in factorial. We are doing the answers in numbers. So what you are getting are the number of ways in which the sum can be done. Yes, thank you, Zeba, Karan, Isha. Thank you. Yes. See, now we will take the word sum. So then you will be able to understand. How many 3-letter words can be formed using the letters of the word square? Okay. Now let us write down the word square. S Q U A R E. How many letters are there? 1, 2, 3, 4, 5, 6. So how many letters are there? N is equal to 6. But how many 3-lettered words? How many 3-lettered words? So R is equal to 3. N is 6, R is 3. Okay. So here in this sum, when I'm writing NPR as the number of words that can be formed from the letters of the word square, how many 3-lettered words can be formed from the using the letters of the word square? So I have NPR is equal to 6P3. Okay, NPR is 6P3. So I try to find this. This is equal to 6 factorial upon 3 factorial. Now, for small numbers up to 7, you need to know, or usually you like it's ones, and here I have 1, 2, 0. So, 123 lettered, 123 lettered, this is L. Let me write it properly. Okay. So, one 3-lettered words can be formed from the letters of the word square. Okay. So can you see simply 6 letters I have? How many 3-lettered words can I form? Form 120. Okay. That is the when I'm talking of this permutation, that N will always be greater than or equal to R. Okay. It will be greater than or equal to R. N will be a positive integer. N cannot be a fraction. N cannot be a negative number. Okay. The same thing applies for R. R also has to be a positive number, or it can and it cannot be a fraction. Okay. Now let us see the other word, hexagon. How many 3-lettered words can I form with the word hexagon? H-E-X-A-G-O-N. 1, 2, 3, 4, 5, 6, 7. So there are 7 letters. So N is equal to 7. What is the value of R? R is 3 because I want to find out 3-lettered word. So what are the number of ways? Number of ways is equal to 7P3, which is equal to 7 factorial upon 4 factorial. Okay. 3 factorial. 7 minus 1. I will show it in detail because it is coming to 4 factorial, but I don't want to write down immediately shortcut. This is equal to 7 minus 4. 7 minus 3 factorial, which is equal to 7 factorial upon 4 factorial, which is equal to 7 into 6 into 5 into 4 factorial upon 4 factorial. This 4 factorial will get cancelled. So you will have 5 6 are 30, 30 7s are 210. So 210 words can be, 3-lettered words can be formed using the letters of the word hexagon. Is that clear? Okay. So I know that NPR is n factorial upon n minus r factorial. Okay. N is 7, r is 3. So this is 7 factorial upon n minus r. So 7 minus 3 factorial, which is equal to 7 factorial upon 4 factorial. You can even write this as 7 factorial. I know is 5040. I know that 4 factorial is 24. So I get the answer as 5040 divided by 24. Answer is 210. So 210 3-digit words can be formed using the letters of the word hexagon. Okay. Bhagdevi, how do you identify N and R? N is the total number of units or total number of objects, and R is the selection that I have to make. Now in this case, the letters in the word hexagon, like in this case, what they are saying is how many 3-letter word can be formed using the letters. Using the letters means that those letters are N. So what are those letters? Those are in the hexagon. 1, 2, 3, 4, 5, 6, 7. So that is why N is 7. And how many words, how many lettered words I have to form? 3-lettered words. So from the 7, I have to select 3 letters each time. And that is nothing but R. Komal, I will check and see what they have written. I don't remember. Okay. Yes, Lakshita, what is your answer then? Okay. For square, the answer is 120. For hexagon, it is. Now let us see this. In how many different ways can 5 persons stand in a line for in a line for a group photograph? So now we have 5 people. Okay. I want to make them stand. So I have these 5 places. 1, 2, 3, 4, 5. Okay. I have 5 places. And in those 5 places, I want to make them stand. So what do I do that? So I have these 5 places. So in this first place, how can, and suppose the people are A, B, C, D, E. These are the 5 people. These are the people. And these are the places. Okay. Okay, because I want them to stand in a photograph. So how many people are available for this position? All 5 are available. Okay, so I have 5 people who are available to stand in position 1. Now one person will stand over here. Suppose I'm asked A to stand over here. So A is standing in position 1. What happened in position 2? How many people are remaining? 1, 2, 3, 4. Any of those 4 people can stand over here. Suppose I ask D to stand here. Okay. So how many people are there? 1, 2, 3, 4. So 4 people can occupy position 2. What happened to position 3? Now D is also standing in one position. You have B, C, and E. So 3 people are available to stand in position 3. So suppose B is standing over here. So B also goes. So in 4th position, in this position, how many people are remaining? C and E. So either C or E can stand over here. So let me say that E stands here. So I have an option of 2 people who can stand over here. Now once E also go, does C have a choice? No. C has to occupy the last place. So how many people? 1 people. Now because I want to make everybody stand in the line, I want to complete the job. So I'm using the multiplication rule. So 5 into 4 into 3 into 2, which is equal to 5 factorial ways, which is equal to 120 ways. Can you imagine this? Can you imagine that there are 120 ways in which you can arrange 5 people to stand in a line? Okay, 120 ways in which you can make 5 people stand for a photograph. Okay, so always remember that this is one method of doing it. Okay, the second is this is for your understanding, and second is that I have to select 5 people from how many? 5 places and 5 people. So N is also 5. R is also 5. Because how many places in the photograph are there? 5 places. So R is also 5. How many people are there? 5. So N is 5. So number of ways will be equal to 5 P 5. So this is equal to, what is this? 5 factorial upon 5 minus 5 factorial, which is equal to 5 factorial upon 0 factorial. Now I know 0 factorial is always 1. Okay, remember this is the clue here. 0 factorial is always equal to 1, which is equal to 5 factorial, which is equal to 120 base. Okay, so the formula method is this. I take N as 5 because there are 5 people. How many places in the photograph are there? 5. So I take R as 5 and I write as 5P5 and this. Or I can use this understanding method also, where I have tried to tell you what it means. It is 5 places. And so for the 5 places, for the first place, how many people are available? 5 people are available. So I write 5. Then for the next place, there are 4 people available. So I multiply by 4. Next place, there are 3 people available to occupy it. So 3, next 2, and next 1. Answer you will always get the same. Whichever method you are comfortable with, you can use that. Okay. So 5 people can stand in a line in 5P5 ways, which is equal to 5 factorial ways. Okay. Now, first, second, and third prizes are to be awarded at the engineering fair in which 13 exhibits have been entered. In how many different ways can the prizes be awarded? Okay. So, 13 exhibits are there. See, importance is on the numbers. So, 13 exhibits are there. How many prizes are there? How many prizes? 3 prizes. How many exhibits? How many exhibits? 13. Okay. So, both methods I will show you. Now, this is prize 1, prize 2, and prize 3. Okay. Remember, usually one person can get only one prize. Okay. So, if anybody has got the first prize, will he get the second prize? No, he's already got the first prize. So somebody else will get the second prize. Somebody else will get the third prize. So let us see if this is the first prize. Okay. First prize. This is the second prize. This is the third prize. How many people are eligible for the first prize? 13 people. Once somebody has got the first prize, that person is removed. How many will remain for the second prize? 12 people. How many will remain for the third prize? 11 people. Okay. 13 into 12 into 11. Let us see how much is this. 13 into 12, 156 into 11, 1716. Okay, this is one method of doing it. The second formula method is N is 13 and R is 3. Total number of objects, that total number of participant or exhibits is 13. How many prizes do I have to select? 3. Okay, among these 13 exhibits, 3 of them are going to get prizes. How many prizes? That are 3 prizes. So, number of ways in which prizes can be awarded. Number of ways in which prizes can be awarded is equal to 13p3. 13p3. So, I know the formula N. What is the formula? NPR is equal to N factorial upon N minus R factorial. Okay, N factorial upon N minus R factorial. So, I will be using this. This is equal to 13 factorial upon 13 minus 3 factorial, which is equal to 13 factorial upon 10 factorial. So, (13) into 12 into 11 into 10 factorial. From 13, I will go up to 10. Okay. From 13, I will go up to 10. So, 13 into 12 into 11 into 10 factorial upon 10 factorial. So, this 10 factorial will cancel with this. We have 13 into 12 into 11, which is again 1716 ways. So, what are the number of ways in which 3 prizes can be distributed amongst 13 participants is 1716 ways. Arya, N will always be greater. I have written, isn't it? See, this is a primary condition. N is greater than or equal to R. So, N is 4 and R is 5 is not possible. I cannot choose more than that I have. Suppose, okay, I have 4 chocolates with me and you want to, Arya is coming to me and saying, I want 5 chocolates. Can I give Arya 5 chocolates? Not possible. I have only 4. So, how can she choose 5 chocolates from my 4 chocolates, right? So, that is not possible. Okay. From given, suppose I have 5 chocolates, then Arya can say, okay, ma'am, I'm not greedy. I want only 4 chocolates. So amongst the 5 chocolates, Arya can pick and choose 4 chocolates. That is possible. But other way around is not possible, where I have less things and you are taking more from it. Okay, that's not possible. Keshav, let me see. Okay. Yeah. Good. So we have all understood. That's great. Okay. Yes. Let us go to the next sum. Yeah. In how many different ways can 3 students be associated with 4 chartered accountants, assuming that each chartered accountant can take at most 1 student? So, this is very important, at most student. So, once you clear your intermediate exams, you will start with your articleship, right? So once you first clear your foundation fast, and then you will clear your one group or both groups of foundation of intermediate, and then you will start with your articleship. So what happens is there are 3 students that are available, and there are 4 vacancies in 4 CA office. So what will happen is, suppose my CA, I have CA A, B, C, and D. Okay. And students, I have student X, Y, Z. Okay. Now the condition is what? That each CA can take up only one articleship. That is necessary. If any CA can take up all 3, then the answer will be different. But we are here talking about the condition that each CA can take up only one article. So suppose X is the first one to go. So how many choices does X have? He can go to either A, B, C, or D. So he has 4 choices, right? Suppose X feels that he is going to be associated with B, CA B. So what will happen? Now I don't have B. Availability of the CA B is no longer there, and X also has been placed at B's office. Okay, so the CA B is not available. Now Y will see that he has 3 options, A, C, and D. So how much does Y have? He has 3 options. Okay, suppose he goes to A. So Y joins A's office. Then what will happen to Z? He has an option of C and D. He still has an option of 2. So 4 into 3 into 2, which is equal, 4 3s are 12, 12 2s are 20. 24 ways in which three students can be placed with 4 CA. Is that clear? Have you understood this sum? This is a typical different sum. So I've taken that. Yes, Devjit, understood? Good. Yes, Ankaldeep, excited? Very nice, very nice. Yes, actually, Aksa. Aska. Okay. Yes, good. You've understood? Yes, Paranita? Vaishnadevi? Vaishnavi. Yes, yes, Vaishnavi. Okay. Next sum, please. Now, if 6 times the number, so you have done, see what? You have done the formula sum. You have done now the word problems. Now we want to see the formula sums which are written in the word format. Okay. So here we have to form that equation. So remember we have done it in 8th and 9th, forming the equations. So same thing is over here. First we have to form the equation and then we have to solve the permutation problem. If 6 times the number of permutations of n things taken 3 at a time is equal to 7 times the number of permutation of n minus things taken 3 at a time. Find n. Okay, if 6 times, the word is very important, and 7 times. So 6 times means 6 into. Okay, 6 times I will write 6 in the number and into. The number of permutation of n things taken 3 at a time. So n p 3 at a time is equal to, okay, is equal to 7 times the number of permutation of n minus 1 things taken 3 at a time. Okay, if 6 times, okay, so if 6 times, let me just write it again so for your understanding. Okay, 6 times means 6 into the number of permutation. The word is important. Number of permutation of n things taken 3 at a time. So NPR, NP3 is equal to 7 times 7 into number of permutation of n minus 1 things taken 3 at a time. So n minus 1 things taken 3 at a time. So 6 into NP3 is equal to 7 into NP. Okay. Now we want to solve this sum. Okay. Now NP3. NPR is how much? NPR is n factorial upon r factorial. Okay. And n factorial can be written as n into n minus 1 factorial. Okay. N factorial can be written as now larger number up to the smaller number. So these are the two important things that I will be using right now. So let us take this. So I will write this as 6 into n factorial upon n minus 3 factorial is equal to 7 into n minus 1 factorial upon n minus 1 minus 3 factorial. Okay. Instead of n factorial, what am I going to write? I am going to write 6 into n minus 1 factorial upon n minus 3 factorial, which is equal to 7 into n minus 1 factorial upon n minus 1 minus 3. So I will get it as n minus 4 factorial. Okay. So n minus 4 factorial. Now what will happen here is n minus 1 factorial will cancel with n minus 1 factorial. So I have 6n in the numerator. Now let us concentrate on the denominator. N minus 3 and n minus 4. Which is the bigger number? N minus 3 is bigger than n minus 4. Okay, because we are subtracting. So that is why I have n minus 3. I will write it in terms of n minus 4. So n minus 3 can be written as n minus 3 into n minus 4 factorial. So n minus 3 factorial can be written as n minus 3 into n minus 4. N minus 3 factorial is written as n minus 3 into n minus 4 factorial. Okay. So there is this factorial sign. Okay, this is equal to How much do you have? 7 upon n minus 4 factorial. 7 upon n minus 4 factorial. Okay. Now this n minus 4 factorial will be cut in the denominator, common out. We take it common out in the denominator. So what we are left with is 6n upon n minus 3 is equal to 7. So this whole equation 6 into n np3 is equal to 7 into n minus 1 p3 is now simplified into this much. So this is 6n is equal to 7 into n minus 3. So I have 6n is equal to 7n. 7 into n is 7n minus 7 into 3 is 21. So 7n minus 6n is equal to 21. So n, 7n minus 6n is n. So n is equal to 21. Okay. So given equation, you have been given equation in the word form. Convert it into the equation form. Write down the equation. Simplify it. Always use the formula NPR is equal to n factorial upon n minus r factorial. Also remember that this is n minus r factorial. Okay. NPR is n factorial upon n minus r factorial, and n factorial is equal to n into n minus 1 factorial. Okay, remember this. This is n minus r factorial. And then when I substitute, I will always try to simplify it by from the bigger number to the smaller number. Okay. Yes, you can. Yes, you can. Priyanka, where do you want to write n minus 4 into n minus 3? Okay, just send me what you want to say. I can't write n minus 4 into n minus 3 only. No, I can't. Okay, if you're talking about the RHS. No. See, just let me explain. Place, okay. What happens here is this, okay. Let us say that n is equal to 7. Then here we are talking of n minus 3 factorial in the denominator. And what is the formula here? 6n upon. Okay, we have 6n is equal to 7 upon n minus 4. Okay. Now let us see. If I already know that n is 7, then what will be my n minus 3? So this will be 6 into 7. And what will be this? This is my LHS and this is my RHS. Okay. This will be 6 into 7 upon n minus 3. So this is 7. This is 7 minus 3. How much is 7 minus 3? That is, this is equal to 42 upon 4 factorial. 42 upon 4 factorial. What will happen over here? This is 7 upon n minus 4. How much is n? 7. 7 minus 4 factorial. So this is how much? This is 7 upon 7 minus 4 is 3. So 3 factorial. Okay. Can I Can I write? Okay, let us see. Can I write 3 factorial is equal to in terms of 4 factorial? No, this is not possible. That is why I can only write 4 factorial as 4 into 3 factorial. Okay, so I can write n minus 3 factorial to be equal to n minus 3 into n minus 4 factorial. Okay, Priyanka, I hope you understood. We always take from the bigger number to the smaller number. Okay, you can't do it in the reverse way. Yes, Rafika, Shubham, good. Yes, thank you. Is that clear? Right? Now this is exercise 5.7. Keshav, which sum do you want? Let me see. Question number 9. Okay. Yes. Now 4P3. From the exercise, this is 4P3. P3 is equal to 4 factorial upon 4 minus 3 factorial, which is equal to 4 factorial upon 1 factorial, which is equal to 4 factorial. Because 4 minus 3 is 1, 1 factorial is 1. So this is 4 factorial. How much is 4 factorial? This is 4 into 3 into 2 into 1. 4 3s are 12, 12 2s are 24. So 24. So P3, 4P3 is evaluated as this would be the correct answer. Is that clear? Yes. Now 4P4. 4P4 is equal to 4 factorial upon 4 minus 4 factorial, which is equal to 4 factorial upon 0 factorial. Remember, 0 factorial is always equal to 1. So the answer is not 0. This is equal to 4 factorial upon 1, which is equal to 4 factorial. So always remember that NPN is equal to N factorial. I think we have written it in the formula bar also. Important formula. Let me check. Yes, see. Can you see over here? NPN is N factorial. Okay. 0 factorial is 1 factorial. Is equal to 1. Understood? So, these are the small concepts that we have applied. So, if you know this formula that NPN is equal to N factorial, don't even have to calculate. You can simply directly, you will know that it is equal to 4 factorial. 4 factorial is 24. Okay. 7 factorial can be written as how much? 5040, right? 0 factorial is a symbol equal to 1. Okay. In NPR, n is always, okay. So, n is always an integer. So, A answer is also correct. But here, they have also given you that it is a positive integer. So, I feel C is the correct answer. But A is also a correct answer. So, depending on what option you have, you can tick that. In NPR, what is the restriction? N is greater than R. N is greater than or equal to R. N is smaller than R or none of these. So, B is the correct answer. So, N is greater than or equal to R. Now, in NPR, N into N minus 1 into the number of factors is how much? Okay, they are asking you how many numbers are there, number of factors. So, when I'm in doubt, I don't know what can I do over here. I will take an example. Let me see 5p2. So 5p2 can be written as 5 factorial upon 5 minus 2 factorial, which is equal to 5 factorial upon 3 factorial. So which is 5 can be written as up to 3. So 5 into 4 into 3 factorial upon 3 factorial. This gets cancelled. This is equal to 20. Okay. This is how I solve. But here they are asking me what are the number of factors. So I will use this formula that they have given. Okay. So 5p2. What is the formula? N into n, n minus 1 into n minus 2 up to where? N minus r plus 1. So how much is my n? N is 5. How much is my r? R is 2. So what will be n minus r plus 1? This will be 5 minus 2 plus 1. 5 minus 2 is 3. 3 plus 1, which is equal to 4. Okay, 3 plus 1 is equal to 4. So from 5, I have to go up to here. This is my 5. And what is this? This is my 4. So how much will I need? I will need to go from 5 to 4. So this is 5 into 4. Because what is 5 minus 1? 4. I've already come over there. So how many factors are there? 1 and 2. So what are the number of factors? R. Because 2 is my R. So R. Okay. You can even see from here. You can even see from here that how many factors remain after cancellation? 1 and 2. So I have 2. Okay. So in NPR, the number of factors is equal to R. So is equal to R. Is that clear? Yes. Keshav, see, I'm taking your sum also. NPR can be also written as, see, they have, instead of using the exclamation mark, they have used this. But I know NPR, I know is equal to n factorial upon n minus r factorial. I only have to change the sign, symbol. So this is n factorial upon n minus r factorial. So A will be the right answer. Okay. Let us take this sum. Now NPR is equal to 12 into NP2. Then N is equal to. So one simple method is I will put the numbers and see whether they are satisfying LHS and RHS. So they should satisfy both. Okay. Now first, this is not an option at all. Okay. Now I have this option 6 and I have option 5. So I will take LHS and I will solve for RHS. What is my LHS? NPR. What is my RHS? 12 into NP2. Okay. So what is this? First option is 6. So I will put 6. 6P4. 4. And this is 2. Okay. 6P4. How much is 6P4? 6 factorial upon 2 factorial. So I have 6 into 5 into 4 into 3. So how much is this? 6 into 5 into 4 into 3 is 360. So this is 360. Okay. 6 into 5 into 4, that is 120 into 3, right? What about RHS? This is 12 into n is 6, so 6p2. So this is 12 into 6 factorial upon 4 factorial. This is equal to 12 into 6 into 5. How much is this? This is also 360. 12 into 30, this is 360. So B is the correct answer. Let us check. What if I had taken n as 5? Okay. What if I had taken this C option? For C option, okay, for C option, that is n is equal to 5. So what will happen when n is 5? LHS and RHS. Let us compare. What will NP4 be? It will be 5P4. 5P4 is 5 factorial upon 5 minus 4, that is 1 factorial. So this is 5 factorial. How much is 5 factorial? 120. RHS is 12 into 5P2. So this is 12 into 5 factorial upon 3 factorial. So this is 12 into 5 into 4. Now 5 4s are 20, 20 12s are 240. So is LHS equal to RHS? No. LHS is not equal to RHS. When I take N as 5, when I take C as the option, so what happens over here? Here LHS is equal to RHS. So I will choose 6 as the correct answer. There is another method, this is the quick way of doing it. So here what has happened is I have already eliminated A option. So I have 2 options on which I need to work. I can also do this by writing this as n factorial upon n minus 4 factorial. Sorry, not r. N minus 4. So n minus 4 factorial is equal to 12 into n factorial upon n minus 2 factorial. Okay. Now n minus 2 I will write up to n minus 4 because n minus 2 is a bigger number, n minus 4 is a smaller number. This n factorial is cancelling out with this n factorial. So I have this 1 minus 4 factorial is equal to 12 upon n minus 2 into n minus 3 upon n minus 4 factorial. Okay. I would write from n minus 2 up to n minus 4. So n minus 2 into n minus 3 into n minus 4. So this cancels. I have got 1 is equal to 12 upon n minus 2 into n minus 3. So what do I do? That is, I have n minus 2 into n minus 3 is equal to 12. Okay. I have n minus 2 into n minus 3 is equal to 12. What are the factors of 12? 12 factors is 4 into 3 or 6 into 2. Can you see that n minus 2 and n minus 3 are consecutive numbers? That is numbers appearing one after the other. So is 6 and 2 appearing one after the other? No. So I will not choose this option. I will choose 4 into 3. So how will I get 4? From which number when I subtract 2 will I get 4? From which number when I subtract 2 will I get 4? So 6. So 4 can be written as 6 minus 2 into 6 minus 3. Okay, 6 minus 4 into 6 minus 3. Okay, so this is equal to 6. 12. 6 minus 4 is 6 minus 2 is 4. 6 minus 3 is 3. 4 into 3 is 12. So here I get n as equal to 6. Okay, n minus 2. Here what have I taken n as 6? Because why did I take 6? Because n minus 2 should be giving me 4 and n minus 3 should give me 3. So what number? N minus 2 is 4. n minus 2 is 4. So n will be equal to 4. This minus 2 when I take to this side, it becomes plus 2. So n plus 4 plus 2, answer is 6. So this is a method. This is the method in which you solve. You should know the method also. But because you have an MCQ exam, let me give the shortcut method also. So I have given the shortcut method first. I am telling you that this whatever options are given, I will try to put those options into the equation and solve and get the answer. Okay. So we have always, Devjit, we have already solved question number 8 also, right? Yes, it is positive integer. Which 7th you want me to repeat? Okay. Yes, I will repeat. Okay, 7th sum you want me to repeat? Fine. See, in these sums, usually you should know this so that you don't spend time. I'm just trying to explain it to you that whenever this question comes in NPR, what are the number of factors? You must know that there are R factors. Okay. I'm just showing you by an example so that it is you, once you have understood a concept, you don't have to mug it by heart. Okay. So this example is there for your understanding. But please remember that here again, it is going to be the same thing, that let us take NPR. So let me give you another example. So let me take that N is equal to 7 and R is equal to 4. Okay, N is 7, R is 4. So 7P4 is equal to how much? 7 factorial upon 7 minus 4 factorial. So this is 7 factorial upon 3 factorial. So 7 into 6 into 5 into 4 into 3 factorial upon 3 factorial, right? So 3 factorial will get cancelled. How many factors are there? That means how many numbers are being multiplied? 1, 2, 3 and 4. Okay. How many numbers are multiplied? 1, 2, 3 and 4. So how many factors? There are 4 factors. Okay. How many factors here? And what is the value of R? R is also 4. So you say in NPR, the number of factors is always equal to R. Okay. All those who had this query, I hope this has been solved. Understood? Yes. Now 10th sum. if NP3, if NP3 upon NP2 is equal to 3:1, then N is equal to how much? Okay. Now, let me see. If I see the option 7, first option is 7, second is 4, third is 5. Okay. So, all options seem to be valid. Okay. Or you can do it in this method, solve it method also. So, I will first show by the solve it method. Okay. NP3. So, N factorial upon N minus 3 factorial. Upon N factorial upon N minus 2 factorial. Okay. This is equal to 3:1. Now this LHS can be written as N factorial upon N minus 3 factorial, and the fraction in the denominator will get flipped. Okay. So this will be written as N minus 2 factorial upon N factorial. So this N factorial will get cancelled. N minus 2, I will write up to N minus 3. So N minus 2 factorial can be written as N minus 2 into N minus 3 factorial upon N minus 3 factorial. This gets cancelled. This is equal to 3. So I get N minus 2 is equal to 3, and I get N is equal to 3 plus 2, which is equal to 5. Okay, which is equal to 5. So I have got this. This is the method. Second method is by putting in the value of N from the option. So let us take the C option, where the option says the value of N is equal to 5. 5p3 is equal to 5 factorial upon 2 factorial. 5 minus 3 is 2 factorial, which is equal to 5 into 4 into 3, which is equal to 5 4s are 20, 23s are 60. Okay. 5p2, which is equal to 5 factorial upon 3 factorial, which is equal to 5 into 4. So, which is equal to 20. So, what will happen? 60 upon 20 is equal to 3:1, which is equal to RHS. Okay, so we started from the LHS and we found that it is equal to the RHS. Okay, so this is the way you can do it. Now, let me even show you how, if I had taken 7 as the option, you would have not got the correct answer. So if I choose if I had chosen N to be equal to 7, okay, the first option, if I had chosen option A, then what would I have? 7p3 is equal to 7 factorial upon 4 factorial, which is equal to 7 into 6 into 5, which is equal to 30 into 7, that is 210. Okay, 7, yes, 210. And 7p2, which is equal to 7 factorial upon 5 factorial, which is equal to 7 into 6, which is equal to 42. So, what will I have? 210 divided by 42 is equal to how much? Which is equal to 5:1, which is not equal to 3:1. Right? So, therefore, what I can find this question, I can solve this question in either ways. I can put the values, I can solve them, and I get the option. Or if you're comfortable, you solve the sum and you will also get the option, correct answer. Okay? Yes. Okay. 8 sum, there is nothing to explain. This is just a way of symbol. Okay. Instead of writing exclamation mark, they are writing like an L. Okay. There is nothing to explain. This is just a way of representation. Okay. Now in the 11th sum, it will be preferable for you to substitute and see, because substitution method will work, because here they have given m plus n p2 and m minus n p2. Okay. So here let us see. Suppose I take the option A. That is m is equal to 6, n is equal to 2. So what will happen here? M plus n is equal to 6 plus 2, that is 8, and m minus n is equal to how much? It is equal to 4. Yes, m minus n. So m plus n. So 8p2. How much is 8p2? 8 factorial upon 6 factorial. 8 factorial upon 8 minus 2, that is 6 factorial. So 8 into 7, this is 56. Okay, so you may be very excited. Okay, A is the correct answer. Wait, you also have another m minus n p2. So let us take that also. M minus n p2 is 4p2. Okay, m minus n is 4p2 is equal to how much? 4 factorial upon 2 factorial. Answer is 4 into 3, which is equal to 12, which is not equal to 30, right? They are saying m minus n p2 should be equal to 30. Are we getting 30? No, 4 into 3. So this is not the correct answer. So A is not a correct option. Let us see B. What will happen to m plus n? It is equal to 8. 7 plus 1 is equal to 8. M minus n, it is equal to 6. 7 minus 1, 6. So what will I have? 8p2. 8p2 is how much? 8 factorial upon 6 factorial, which is equal to 56. Now m minus n is 6. So 6p2 is equal to 6 factorial upon 4 factorial. So this is 5 into 6, which is equal to 30. So A is also satisfied, B is also satisfied, because see, both conditions have to be satisfied. I should get this answer also and I should get this answer also. So here I've got both the answers correct. So I get B to be the correct option. Okay, understood? So we will be taking up more examples next time, because we have another session for permutations and then we will have one session for combination. So I hope you've understood the concepts of permutation, where we are arranging given objects in a set. We have talked about how permutations and combinations are used in real life. Also, like in permutation, you are using it in biology, you are using it in computer science, and even in finance sector also, we are using permutations and combinations. Okay, so have a wonderful day ahead, and thank you for your patient listening. Thank you. Have a great day. Yes. Hello. I finished with my session.